So in my previous video, I posed you a couple of questions on working with the equations of straight lines. What I'm going to do in this one is I'm going to take you through those questions, show you the answers, show you how to work them, and see what you got. So just a quick refresher for you. These are the questions I asked. So first, calculate the equation of the line joining the 2 points. So the first one gave you the points -2, -3, and 6, -1. And the second one gave you the 2 points 3, -4, and -5, 2. Then the second question was, what is the equation of the line parallel to 3x plus 4y equals 12, going through the point 1, 4. So let's have a crack at these. So the first one was, I want the equation of the line joining these two. Now remember, the equation of a straight line takes form y minus b equals mx minus a. That's how we have to get it. We then take that and work it to get to a form y equals mx plus c. Now for this form here to come through, we need two things. We need an m, which is our gradient, and we need the a and the b, which come from a generic point on the line, or a point we use to calculate it. Now it doesn't matter which point we use. We've proven in the previous video we get the same answer regardless. But these are the two things we need to do. So the first thing we should always calculate is our gradient. So let's start with that. So m equals, so we know it's y2 minus y1 over x2 minus x1. So we substitute in the values and we go for it. So if I said this point here was x1, y1, and this point here was x2, y2, what I'd end up getting is -1 take away -3 over 6 take away -2. -1 take away -3, minus minus becomes a plus, so it's -1 plus 3 gives me 2, and then 6 take away -2 gives me 6 plus 2, which is 8. So I get 2 over 8, which simplifies down to a quarter. So what I can then do is pick either of these 2 points, plug it all together, and I should get the same answer regardless. Now do yourself a favour, pick the easier of the two to work with. Sometimes that's more obvious, sometimes neither of them really have a distinct advantage. In this one I'm just going to pick the second one. So I do for that, so y minus b, so it's y minus minus 1, so y plus 1 equals m, so a quarter, bracket x minus a, which is x minus 6. Then it's a case of just multiplying it all out. So I get y plus 1 equals a quarter x, take away 6 over 4, which is 3 over 2. Take away 1 for both sides, and I get y equals a quarter x minus a half. Now, that's one way of leaving it. Another way of leaving the general equation of a straight line is ax plus by plus c equals 0. So I could take this and manipulate it that way. So if I get rid of the fractions by multiplying everything by 4, what I'd end up getting is 4y equals, well, a quarter x times 4 is just x, take away a half times 4, which is 2. Plug it all together on this side across here, and I get 4y minus x plus 2 equals 0. So I could have either version of that as the equation of my straight line. Depends on how it asks you. Sometimes if it says the general equation of a straight line, it's this one that it's after here. Second example was the points 3, -4 and -5, 2. Again, we need the same bits of information. We need a point A, B, we've got 2 of them, and we need the gradient. So let's start with the gradient. So I know again, y2 minus y1 over x2 minus x1. And we stick with labeling the points, x1, y1, and x2, y2. As we said before, it doesn't matter which way around we label them as x1, y1, x2, y2, as long as we don't mix those parts up. So if I labelled this as x1, y2, and this is x2, y1, that would cause an issue. But not labelling them this way. So y2 minus y1 gives me 2 take away -4 over x2 minus x1 over -5 take away 3. 2 minus minus 4, 2 plus 4, that gives me 6. -5 take away 3 over -8. So that then ends up giving me -3/4. So my gradient of my line is given by that. What I then do is plug it into my y minus b equals mx minus a. So I'm going to pick this point here and then plug that in. So y minus b, y minus 2 equals m, so -3 over 4, bracket x minus a, so it's minus minus, so it becomes x plus 5. And again, it's about getting rid of the fraction and getting it all the way that we want it to be. So I'm going to get everything multiplied by 4 just to get rid of the bottom of this. So I get 4y minus 8 equals -3x minus 15, and then plug it all together on the one side. So I get 4y plus 3x, I've got -8 plus 15 plus 7 equals 0. There's the equation of my straight line. Again, I could have had it in the y equals mx plus c form if I really wanted to at this point. So I could have had it as y minus 2 equals negative 3 quarters x, take away 15 over 4, shift the 2 across, and I get y equals negative 3 over 4x. It's then minus 15 over 4 plus 2, so it's minus 15 over 4 plus 8 over 4 gives me minus 7 over 4. So I could have had it in that version as well. Either's fine. Again, general equation of a straight line, this is the one we'd really be looking for. Now the last question I asked you, what was the equation of the line parallel to this one through the point 1, 4? Well, again, we need a gradient, but we don't have 2 points for it. However, we've got a key bit of information. Parallel. Think of two lines as a train track. Parallel to each other means they're running alongside each other and they'll never meet. When you've got two lines like this, that means the gradients are equal. So the gradient of the line I want is equal to the gradient of this. So I have to rearrange this into my form y equals mx plus c, and then I'm able to read off my gradient. So take it, start to rearrange it, and I get 4y equals negative 3x plus 12. And if I divide everything by 4, I get y equals negative 3 quarters x plus 3. And there's my gradient in there. I know my gradient is equal to negative 3 over 4. Then it's a case of just using my general equation. So my y minus b equals mx minus a. My m comes from this, negative 3 over 4. We've just calculated it. And there's my a and my b, my point I've been given. So I've got y minus 4 equals negative 3 quarters bracket x minus 1. And again, it's just a case of multiplying it out and simplifying things down. 4y minus 16 equals negative 3x plus 3, and then punt everything to one side. So I get 4y plus 3x. I've then got negative 16, take away 3, minus 19 equals 0. Again, if I'd wanted the y equals mx plus c version, I would then do y minus 4 equals negative 3 quarters x plus 3 quarters, and then shift the 4 across there. I get y equals negative 3 over 4 x, and then adding 4 on, so I get plus 19 over 4 there. Either version's fine, but again, general equation of a straight line, we tend to try and stick to this version here at higher. So there you go, a few easy questions for you to have a crack at. See you in class, we can go over a few more.